Hey everyone, and welcome back. Today we're diving into a world where AI can write poetry,
Oh, wow.
compose music, and even help design new drugs.
Really amazing stuff.
We're talking about generative AI and natural language processing, or NLP. And to guide us, we'll be using excerpts from Generative AI and NLP.pdf.
Sounds good.
So, for those who might be new to these terms, let's start with the basics.
Okay.
What exactly is generative AI?
Well, imagine AI that doesn't just recognize patterns,
Yeah.
but actually creates something new based on those patterns.
Okay.
That's generative AI in a nutshell. Think about those AI-generated images that are making waves online.
Mm-hmm.
You see those photorealistic faces that don't even belong to real people.
Yeah.
That's a prime example of what generative AI can do.
So it's not just about analyzing data, it's about creating something entirely new.
Exactly. It's about going beyond recognizing a cat in a photo
Mm-hmm.
and actually generating a whole new image of a cat, complete with unique features and details.
And this goes beyond images, right?
Absolutely. Generative AI can create text music, 3D models, you name it. And its roots go back further than you might think.
Oh, really?
Back in the 1950s, Alan Turing, a pioneer in computer science, proposed a test for machine intelligence. That essentially laid the groundwork for what we now call generative AI.
Interesting.
But it wasn't until the 1980s, with the rediscovery of the backpropagation algorithm, that we saw a real turning point.
Backpropagation, that sounds pretty technical.
It's a mouthful.
What's the significance of that?
Well, it revolutionized the way we train neural networks, those brain-inspired structures that power AI. Backpropagation made it possible to train much more complex networks, leading to significant advancements in the field.
I see.
And then in the 2010s, we saw another major breakthrough,
Okay.
the emergence of GANs, or generative adversarial networks.
GANs, those are the ones that create those hyper-realistic images, right?
You got it. GANs are a specific type of neural network architecture where two networks are essentially competing with each other. One network generates data, and the other tries to distinguish between real and generated data. It's like a constant game of cat and mouse, pushing both networks to become better and better.
So it's like competition breeds innovation, even in the AI world.
Exactly. And that competition has led to some truly remarkable results.
Now let's shift gears a bit and talk about NLP, or natural language processing.
So
This is all about teaching computers to understand and work with human language.
that's right. NLP is about bridging the gap between humans and computers when it comes to language. You know, we use language in such a nuanced and complex way,
Uh-huh.
with context, tone, even sarcasm, playing a role in how we convey meaning. NLP aims to give computers those same abilities.
That sounds like a monumental task. How do you even begin to break down human language for a computer?
It's definitely a huge challenge, and it involves a combination of techniques. There's syntax, which is like grammar rules for computers, and semantics,
Okay.
which is about figuring out the meaning of words and sentences.
So it's not just about recognizing individual words, it's about understanding how those words work together to create meaning.
Exactly. And there's another layer called morphology, which deals with word structure.
Morphology.
Yeah, think about how adding ed changes a verb to past tense. Morphology helps computers understand those little building blocks of words.
I see. So it's really about understanding all those subtle nuances that we take for granted when we use language.
Precisely. And then there's pragmatics, which deals with the role of context in language.
Okay.
For example, the phrase break a leg can mean good luck depending on the situation.
Right.
NLP aims to give computers the ability to grasp those contextual nuances.
So it's about mimicking our own cognitive processes to make communication with machines smoother and more natural.
Right.
What are some real-world examples of NLP in action, things that people might interact with on a daily basis?
Think about those machine translation tools like Google Translate that allow you to understand websites in different languages, or those chatbots that are becoming more prevalent on websites and apps.
Yeah.
They're powered by NLP and becoming increasingly sophisticated in their ability to hold conversations. And then there's sentiment analysis, where companies can analyze online reviews to determine whether people are generally happy or angry. That's NLP at work as well.
So we've got generative AI, the creator side, and NLP, the language side. How do these two fields actually connect?
Well, NLP provides the foundation for many generative AI applications.
Uh-huh.
Imagine a chatbot that can generate responses that sound like they're coming from a real person. That's where the magic of NLP and generative AI come together.
Okay.
Generative models powered by NLP techniques learn the patterns of human language and use that knowledge to create new text that mimics human conversation.
So it's like NLP provides the building blocks of language, and generative AI uses those blocks to construct something new and creative.
That's a great way to put it.
Now let's dive a bit deeper into the core components of generative AI.
Well,
The source material we're using mentions machine learning basics. What's essential for us to understand there?
one key distinction is between supervised and unsupervised learning.
Okay.
Supervised learning is like having a teacher. You feed the AI labeled data, like images tagged with cat or dog, and it learns to classify new images based on that training. Unsupervised learning is more like letting the AI explore on its own. It finds patterns in data without those explicit labels, which is quite powerful for tasks like grouping similar items together.
So it's like the difference between having a guide and exploring a new city on your own.
That's a great analogy. And then there's deep learning, which is a subset of machine learning that uses neural networks to analyze data.
Deep learning, that always sounds a bit intimidating.
Yeah, I know what you mean.
Can you break that down for us?
Think of it like this. Deep learning involves using neural networks, those brain-inspired structures. To analyze data, these networks have multiple layers, which is where the deep comes in. Each layer processes information and passes it on, allowing the network to learn increasingly complex patterns.
So it's like having a team of experts, each specializing in a specific aspect of the problem, working together to solve it.
Exactly.
And we talked about GANs earlier. How do they fit into this whole deep learning picture?
GANs are a type of deep learning architecture that uses two neural networks pitted against each other. One network generates data, and the other network tries to distinguish between real data and the data generated by the first network.
Okay.
This constant back and forth pushes both networks to improve, leading to increasingly realistic outputs.
It's like a constant game of one-upmanship driving innovation in the AI world.
Precisely.
Okay, I'm starting to get a better grasp of how all these pieces fit together. Now let's talk about language models.
Okay.
What are those and how do they relate to NLP?
Language models are all about predicting the next word in a sequence. Think about those predictive text features on your phone. Language models are essentially a much more advanced version of that. They learn the statistical relationships between words and use that knowledge to generate text that sounds natural and coherent.
So like predictive text on steroids.
You could say that.
Yeah.
And within language models, we have different types. Early models were purely statistical, relying on simple word frequencies and probabilities. But then came neural language models, which use, you guessed it, neural networks to capture more complex patterns in language.
Neural networks, they seem to be at the heart of so much progress in AI.
They play a crucial role.
Okay, so we've got these neural language models. What comes next in our generative AI and NLP journey?
Well, next up, we'll delve into some specialized types of neural networks designed for handling sequential data, like language.
Okay.
Get ready to hear about LSTMs and GRUs, terms that sound like they're straight out of science fiction.
I'm all ears. Sounds like we're about to go even deeper into the fascinating world of language and AI.
LSTMs, which stands for Long Short-Term Memory Networks, and GRUs, or Gated Recurrent Units, are both types of neural networks that are particularly good at dealing with sequential data like language.
I'm trying to picture how that works. Why are those better for language specifically?
Well, think about reading a book. You need to remember information from previous chapters to understand what's happening in the current chapter, right?
Right.
LSTMs and GRUs have a similar kind of memory mechanism that allows them to take past context into account when processing new information.
So it's like they have a built-in bookmark that helps them keep track of the important plot points as they go along.
That's a great way to think about it. And this ability to handle long-range dependencies is a big part of why LSTMs and GRUs have been so successful in various NLP tasks.
I can definitely see how that would be important for things like understanding the flow of a conversation or the structure of a story. Now, the source material mentions something called transformers. They're described as a real game changer in NLP. What's so special about them?
Transformers introduced a mechanism called self-attention, which allows the model to focus on the most relevant words when predicting the next word in a sequence.
So instead of just looking at words in isolation, it's able to understand the relationships between words, even across long sentences.
Exactly. Imagine you're reading a sentence, and you highlight certain phrases that seem particularly important for understanding the overall meaning. Self-attention allows transformers to do something similar. It helps them grasp the context and figure out which words are most relevant to each other.
It's like they have a built-in highlighter that helps them zero in on the key parts of a sentence. That's a pretty powerful capability. I'm guessing this led to some significant advancements in the field.
Absolutely. Transformers have revolutionized NLP, paving the way for a whole new generation of language models that are more powerful and versatile than anything we've seen before. One example you've probably heard of is BERT.
BERT, yes. I know that's a pretty big deal in the NLP world. What makes it stand out?
BERT, which stands for Bidirectional Encoder Representations from Transformers, is known for its ability to understand context from both directions in a sentence.
What do you mean by both directions?
Think about it this way. When you read a sentence, you understand the meaning by considering the words that come both before and after a particular word. BERT is able to do the same thing. It's like reading a sentence forward and backward simultaneously to get the full context. This bidirectional approach allows it to capture nuances of meaning that earlier models often missed.
That's impressive. It sounds like BERT has a real edge when it comes to understanding the subtleties of language.
It certainly does, and this has made it a popular choice for a wide range of NLP tasks, including question answering, sentiment analysis, and text summarization.
So we've talked about language models, transformers, and BERT. Are there any other key players in the world of NLP that we should know about?
Definitely. There's a whole ecosystem of advanced generative models that are specifically designed for NLP tasks.
Yeah.
Two notable examples are GPT-3 and T5.
GPT-3, that's the one that's been making headlines for its ability to write creative text right. Is it really as amazing as everyone says?
GPT-3, which stands for Generative Pre-trained Transformer 3, has certainly garnered a lot of attention, and for good reason. It's a massive language model developed by OpenAI, and it's capable of generating incredibly human-like text. We're talking everything from writing poems and stories to translating languages and even coding. In fact, there's a descendant of GPT-3 called Codex that powers GitHub Copilot.
GitHub Copilot, what is that?
It's an AI-powered tool that helps programmers write code more efficiently. Imagine having a virtual assistant that can suggest code snippets, complete functions, and even generate entire blocks of code based on your comments.
Wow, that sounds like a dream come true for any developer. Are there any other models that are pushing the boundaries of what's possible in NLP?
Absolutely. T5, which stands for Text-to-Text Transformer, is another impressive model. It was developed by Google and is known for its versatility. What's interesting about T5 is that it approaches every NLP task as a text-to-text problem.
So instead of having different models for tasks like translation and summarization, you can use one model for everything.
Exactly. Whether it's translating a sentence, summarizing a news article, or answering a question, T5 can handle it all by converting it into a text-to-text format. This makes it incredibly efficient and adaptable.
That's a really clever approach. It's like having a Swiss Army knife for NLP tasks.
Precisely.
Why?
And these models are constantly being improved and refined. It seems like every day brings news of a new breakthrough or a new application.
It's truly mind-boggling how fast this field is moving. I'm eager to see what the future holds. So we've talked about all of these amazing things that AI can do, but how is all of this actually being used today? How are these technologies actually being applied in the real world?
Well, that's a great question, and one of the most exciting areas where we're seeing a real impact is in healthcare.
Healthcare.
Yeah, imagine a world where doctors can spend less time on paperwork and more time with their patients. That's the promise of generative AI in healthcare.
That would definitely be a good thing. I'm curious, though, how is this actually being used in hospitals and clinics?
Well, one application that's gaining a lot of traction is the use of AI for clinical documentation, specifically transcribing and summarizing patient-doctor interactions.
So like during an office visit?
Exactly.
Yep.
Think
Yeah.
about those typical doctor's appointments where the doctor is constantly taking notes. It can be distracting for both the doctor and the patient.
Yeah, I can imagine that. I've definitely been in those appointments where I felt like the doctor was more focused on writing than on me.
Exactly. And that's where AI can really make a difference. Hospitals are now using AI-powered systems that can listen in on those conversations during consultations, transcribe what's being said, and then generate concise summaries. That can be added directly to the patient's electronic health record.
So it's like having a virtual scribe that captures everything accurately and efficiently?
We got it. And it goes beyond just documentation. We're also seeing the emergence of conversational AI for diagnostics. Think about AI-powered chatbots that can answer patient questions, provide preliminary diagnoses, and even recommend next steps based on symptoms.
That's incredible. It sounds like something straight out of science fiction,
It does, right?
but it's actually happening right now.
It is, and these chatbots are becoming increasingly sophisticated. They can access vast amounts of medical knowledge and use complex algorithms to analyze symptoms and provide personalized guidance.
Okay, but are these chatbots actually meant to replace doctors?
Of course, they're not meant to replace human doctors, but they can be a valuable tool for triaging patients and ensuring that they get the right care at the right time.
So they could actually help patients get seen faster.
Exactly. And it's not just about efficiency. There's also the potential for AI to revolutionize medical research and drug discovery. AI algorithms can analyze massive data sets of patient information, identify patterns, and potentially discover new treatments.
Wow, so we've got all this amazing potential. But with great power comes responsibility. What are some of the ethical considerations around AI in healthcare?
That's a really important question, and it's something that researchers and developers are very mindful of. One of the key concerns is ensuring that these AI systems are fair and unbiased. We need to make sure that they don't perpetuate existing inequalities in healthcare.
That makes sense. So we have to make sure that these systems aren't making things worse.
Exactly. That's why it's essential to use diverse and representative data sets when training these systems, and to carefully evaluate their performance to make sure they're not discriminating against certain groups of patients.
And what about patient privacy?
Yeah, another ethical consideration is transparency. It's important for patients to understand when they're interacting with an AI system and to have control over their own data.
So patients need to be informed and empowered.
Absolutely. Patients need to feel confident that these AI systems are being used ethically and in their best interests.
This has been such a fascinating conversation, and I think it's clear that generative AI and NLP are already having a major impact on our world, and it seems like we're just at the beginning.
I agree. It's an incredibly exciting time to be working in these fields, and I believe that these technologies have the potential to truly transform our lives for the better.
Well, I couldn't agree more. Thanks so much for joining us and sharing your expertise.
It's been my pleasure.
And to all of our listeners out there, thanks for tuning in. We hope you've enjoyed this deep dive into the world of generative AI and NLP. Until next time, stay curious and keep exploring.